Sorry
This
for the
conference will now be recorded.
So wait for a few minutes. It should be opening here. Students, are you hearing my voice? Students, please reply me. Are you hear my voice? Students, are you able to listen my voice? Right. We will today we are going to discuss about the capacitance of a transmission line. See, until now we discussed about the inductance and how the inductance value for different types of connections. I mean, in the terms of single phase and three phase, and we derived too many derivations, and based on the structure how we can get the derivations for inductance and the reactance value of inductance, and we did a few more problems on this inductance. Now one of the most important parameter of transmission line now we are going to discuss, that is capacitance. See, in transmission line we have the three types of parameters. One is resistor, inductor, and capacitor, and these three having the different type of importance in the transmission line. So already we know that what is the importance of inductance in a transmission line. Due to that inductance, what are the losses we are obtaining in the transmission line, how we can minimize that. So that was how we discussed here. Now the next topic is the capacitance of transmission line. That is the most important topic, and it is useful for that calculating the capacitance of a transmission line. So why? Because are you able? Are you aware about capacitance of a conductor? See, let me consider a conductor here. This is a conductor. When the current flowing through the conductor, the charges should be moved from one place to other place. Already, you know the basic definition of capacitor. The capacitance of a conductor is Q1 Q2 divided by D square. Here Q1 Q2 is nothing but the charge available at one end and second end, and the capacity is most probably occurring based on that the voltage difference occurring in the end of the conductor. See, if we consider this conductor, there is a potential difference between this across. How we can obtain the potential difference means based on the charges. Why? Because the charges available on the conductor are starting and ending both are different. So let's consider C1, C2 are the two charges available on the both ends and divide by this that distance between these 2 points. So that is what that was given by that capacitance. Now we'll see that what are the parameters, how we can calculate the capacitance, and what are the parameters are influencing the capacitance of the transmission line. Right. See, I already told you that due to the potential difference between the conductors, suppose let me take the conductor here. So if you take the conductor, due to the excitation, there is a flow of charges among this distance. Now, when the charges is flowing, due to this charges moving, there is a occurring of potential difference across the conductor, and it's made taken out into the account of capacitance. When the potential difference is occurring in a conductor, there is a need to make the capacitance, and this capacitance gives that what is the capacity of a conductor, and based on the capacitance, and it can allow the more power. Right. So already we know that the conductors, the transmission lines are capable to transfer the more power. How we can send the more power means by taking into account of capacitance. If it has the more capacity, then it can be able to transfer the more power. Now we have to analyze that capacity of a transmission line means. So if you take the transmission line, how much of capacity it having. See, generally, if you take the single phase transmission line, so this is fierce and it is neutral. In these two lines, one of the conductor is acting as a positive plate, and the other neutral line is acting as a neutral plate. So you know that capacitor symbol, right? See, it means it's looking like, so it is a phase and neutral. It's looking like a parallel plate capacitor, right? So it should be like this. Now, if when it will happen means when the two conductors or two plates are connected in parallel to each other. So it means that there is a potential drop occurs between the two plates, and the capacitance between the conductors is the charge per unit of potential difference. It means that how much of charge is flowing per unit area, and what is the potential difference across occurring across between the capacitance. And between the parallel conductors, the capacitance is constant, which depends on size and spacing of conductor. And it is a more important term. Why? Because see, some of the transmission lines are based on the capacity of a power, the size should be differ. Suppose if you take the bundle conductor, its diameter will be more. If you take solid conductor, it is a one conductor, and its diameter will be more. So based on the size, the capacitance will be calculated. And one more important parameter here: if the transmission line is length is less than 10 kilometer, in this condition, the calculation of capacitance, the consideration of capacitance is completely negligible. Why? Because due to the capacitance, the losses will be, the changes occurring in the transmission line is very rare. So when it is very rare means when the transmission line is below less than 80 kilometers, the effect of capacitance is assumed to be negligible, and it is not taken into the consideration. So keep remembering this point. The capacitance should be, so in some authors they define that less than 100 kilometers like that. So let me consider approximately if the transmission length is less than 10 kilometers, we are not considering that any capacitance value parameters in that particular line. Why? Because the drops due to the capacitance will be very less. So that's why that is the introduction about what is the role of capacitance, how we can calculate the capacitance in the transmission line. Let's move on the next slide. Right. Now, I told you that the capacitance value should be depends on the length and spacing between the conductors. Even though, but increasing the length of the transmission line along with high voltage. Suppose if you are taking that a three-phase transmission line, it carries that high voltage, like 400 kV, 200 kV. It means that in this condition, the effect of capacitance becomes prominent and important in analysis. Why? Because when there is a most huge amount of voltage is flowing, there is amount of potential drop occurs in between the both ends. So when the potential difference is occur in the transmission line, there will be a capacitance including in that parameter. Now, when the alternating voltage is impressed on the transmission line, it causes a charges. Why? Because suppose in transmission line we are getting the waveform should be in sinusoidal, right? Due to the sinusoidal waveform, the charges occurring, that is some of the charges may be increasing some due to that sinusoidal waveform. In off period it should be charging, and off period it should be discharging. Based on these up and down conditions, there be a flow of current. That current is called as charging current. So that is this most important thing. So you may get 2 marks. What is the charging current means? Due to the alternating current, due to alternating charging and discharging of the line, a current starts to flowing in the line. Thus this current is called as charging current. And this current is flows even the line is open circuited. So in transmission line, the capacitance has the vital role in the power capability. Why? Because some of the we are in transmission line, we are using the some flash device, that is flexible AC transmission system. So fax device we are using in the transmission lines for reactive power control. So when reactive power control is needed means when the losses will be occurring in the transmission line and when the load is changing in the transmission line. Due to these two reasons, the reactive power will be changing the transmission. Generally, our power is equals to the generation power is equals to P plus jq. It is a combination of this is called as complex power, and it is a combination of real and reactive power. Now in transmission line, the power when compared to the two power, that is real power and reactive power, there are most changes occurring in the reactive power. So it means that for for obtaining the stability of voltage, we have to make that reactive power control. So how we can make the reactive power control means we need some boost converters, boosters. So in that boosters we are considering as a capacitor, and this capacitors can be used as a fax device in the transmission line. Fax means flexible AC transmission system. So just remember this abbreviation. Fax is a flexible AC transmission system. The name itself indicates that this type of device makes that flexible transmission in the flexible power of transmission in the transmission line. And so due to this sinusoidal waveform, so it means that we are our transmission lines are most probably we are using the AC transmission system. In that, based on this sinusoidal waveform, the charges may sometimes it may be charging and discharging based on the waveform. And due to this due to this condition, the current will be flowing in the transmission line, and this current is called as charging current. And this current flows even the circuit in open condition or open circuit. That's why the capacitance is always connected in parallel to the conductors. It means that some at circuit connection it acts as a load. After when circuit is open, it acting as a source. It means that when the supplies keep on going to flowing, at that time the capacitor should be charging up or booster. When the circuit is opened, at that time it is acting as a source. Now the voltage drop along the line is affected due to this condition, that is due to charging and discharging, and it also affects the efficiency and power factor of the line and stability of the transmission system. To rectify this type of problem, that is efficiency, power factor and stability, we are supposed to use that fax device. Then only we can maintain these three parameters and three behavior of the transmission line. Why? Because if you use the fax device, we can maintain the reactive power. So that is called as reactive power control. So based on this topic, you will get one subject, reactive power control of transmission system. So it is the most important concept in the transmission system. So our main agenda is we have to maintain the reactive power to deliver the load to the customers with purity of power supply. So how we can get that purity of power supply means when we maintain the reactive power is a perfect manner, when it's stabilized in manner. So that is the capacitance involving in the transmission line. Now let me move to the next slide. Students, now my voice is audible. Can you hear my voice? Right. So next one is right. So previously we discussed about what is the inductance of a transmission line, how we can calculate that inductance value, and what are the inductance value with respect to the types of connection. It may be single phase and three phase. In that, while we talking about inductance value, we know the equation that L is equals to psi by I. Now, in this condition, we are talking about magnetic field. So when we talk about when we are considering the inductance value, so there is involvement of magnetic field, and when we are considering the capacitance value, there is involvement of electrical field. So these two are two major parts while involving that while calculate the inductance and capacitance value. Keep remember that while considering the inductance, it is completely depends on the magnetic field, and while similarly while working with capacitance, electrical field plays an important role. Why? Because the capacitance should be happen based on that how much of potential, how much of charges will be flowing in the conductor, and thus that flow on charge is called as electrical field. Now this electrical field lines originate from positive charge and terminate at negative charge. Now I will show you one video, then you will get clarity on this. And the amount of capacitance between the conductors is a function of conductor radius, spacing, and height of the above. So these three parameters are involving vital role in the capacitance value. So now I will show you video. Then you will get clarity on this. How the capacitance having, how the charges will be moving in the capacitor.
Capacitors and capacitance. Capacitor is a device which is used to store large amounts of charges at low potentials. It is a system of two conductors separated by an insulating medium. The intensity of electric field is proportional to charge carried by conductors. As intensity increases with potential difference V, it can be said that V is also proportional to charge. That is, V is directly proportional to Q, or Q equals to CV. C equals to Q by V, where constant of proportionality C is called.
See here that in this that positive charge Q. So it means that here to the conductor the positive Q charges are entering and negative charges are leaving, right? So here the positive charges are entering to this parallel capacitor. So this is positive Q, and here from this cap negative charges will be leaving that. So it means that when we are applying the potential to the conductor due to the electrical field, the positive charge is entering to the transmission line and negative charges are leaving from the transmission line through the air gap. So this is called as air gap, and it is denoted by mu naught. That is free space value.
Electric capacitance, the capacitor. If V equals to 1, then C equals to Q. Thus, capacitance of a conductor may be defined as amount of charge that should be given to raise its potential by heating. SI unit of capacitance is found as 1S equals to 1C by 1V. 1S equals to 1C V inverse. 1 UF equals to 10 power minus 6 F. 1 S equals to 10 power minus 7 F. 1 VF equals to 10 power minus 12 F. Capacitor is symbolically represented as below.
So it means that sure, see here the capacitance in
బీరకాయలు ఆనియన్
see here the capacitance in that the amount of the electrical field lines originate from positive charges and terminate and negative charges. It means that in electrical field lines the positive charges are entering into the parallel capacitors and terminates at negative charge capacitors. Now the amount of capacitance should be depends on that conductor radius as well as spacing and height above from the ground. Now we will find that what is the electrical field and what is the potential drop across the in the conductor. Now, so let me take the one solid conductor. So suppose it should be like this. Now, when the electrical field is flowing here, and due to this electrical field, there is the occurrence of charges that is let consider Q. So here, this circle is called I am considering is solid conductor, and due to the electrical field, the positive charges will be occurring, and it should, let consider one outer area, and it is isolated from other charges. It means that so some neighbor conductor also presenting the charges, right? So that charges I am neglecting here. The flux lines are radial to each other. So radial in the sense they are equal in distance. Now the electrical field density D at x meters. Now we have to find that density of the electrical field from origin of the conductor, that is center point of the conductor, to the some distance. Let's consider it is x meters. Now by assuming a cylindrical surface concentrating with the conductor and x meters in radius. Now let this distance is make that as a radius. Now from this construction, let me take that what is the capacitance will be calculated based on this condition. Now if you want to find the capacitance, we need some two parameters. One is electrical field density and electrical field intensity, electric field. So these two are we need. So one is electrical flux density and electrical field. By using these two parameters, we can calculate the capacitance of the conductor. See here, as all parts of surface are the same distance. Now if you take the solid conductor here, if you are from the center, you can take any distance, any radius, it has the equal distance, right? So that means that it has the equal surface. Now when this conductor surface is equal, the electrical flux density is given by how much of charge will be generated with respect to the circumference of the, so it is in the form of circumference, right? So you can write Q divided by 2 pi x. So here R is instead of R, I'm taking the xy because our radius from the origin is x, right? Generally the circumference of the circle is 2 pi r. Instead of R, I'm taking the xy because our radius, I'm considering the radius from origin to the some point, it is x. So that's why Q is equals to Q by 2 pi x. What is meaning by C by m square? So here electrical flux density denoted by C by m square, right? What is C here? What we call C here? So we call C. So the electrical flux density units is coulomb per meter square. Now here the Q is a charge on the conductor and x is the distance from the conductor to the point where it is required to find field intensity. So we are taking the distance. So this is the point. Up to, at this point, we have to find that what is the field intensity due to the charge q. So this is the equation. This is the formula is given by the electrical flux density due to the charge at circumference of the conductor with equal distance. Now we'll find that electrical field, electrical flux intensity. Now the flux, if the field density is divided by the permittivity of the medium, then we will get that electrical flux intensity, and it is generated by E, and it is given by capital D divided by epsilon. So already we found that D value, right? So D is we got Q divided by, so that is the electrical flux density, Q divided by 2 pi r 2 pi x. Now, if you substitute here, you will get Q divided by 2 pi epsilon x. So here epsilon is a permittivity, and it can be written as mu naught into mu r. Here mu naught is the permittivity of free space, and it is given by 8.85 into 10 power minus 12 farads per meter. Now here in the same time in inductance we are considering mu is equals to mu naught into mu r. So this is used for the magnetic field, and it is used for the electrical field. So this is the difference between magnetic field parameters and electrical parameters. Here we considering mu naught is equals to 4 into 10 power minus 7. But here the epsilon naught is equal to 8.85 into 10 power plus 12. So it is minus 2, sorry. 10 power minus 12 farad per meter, and the relative permittivity is equal to 1. So here also the nu r is equal to 1. Now as x approaches to infinity, now if you observe from this equation, if you observe this equation, when x equals to when x is reaches to the infinity, then you will get the flux intensity will be 0. So same thing here. Whereas the x approaches to infinity, the value of E approaches 0. Therefore, the potential difference between the conductor and neutral point at infinity, so is given by VA. So we are considering the voltage of the conductor A, and its value should be its electrical field vary from R to infinity. Here it means that, so we are considering from here to here x parameter, right? So x meters, and this is called as radius. Now from this radius, how much of travel to the infinity, what is the charge along with the respect to the potential difference, and it is given by integration of r to infinity qa divided by 2 pi epsilon max. So here q and 2 pi epsilon is completely constant value, and it is depends on what is the distance between that rate from the center of the conductor to the outer surface, that is the outermost area. So here that is given by the dx by 1 by x. So integration of, we already know the integration of 1 by x is equals to ln x. So this is the voltage of a conductor A with respect to the integration from the distance of r to infinity. Now we'll find that. So just now we find that what is the electrical field with respect to the charges and distance of a conductor. Now we can consider that what is the potential difference between the 2 points. Now so again I am considering the conductor here, and this conductor will create the positive charges, and due to the positive charges the field will be circulating to them, and towards it moves like this. Now, in this waveforms, I am considering the 2 points. One is P1 and P2. We are having that with the distance D1, D2 from the origin. Now, if you take in this path that is created by the P1 and P2, it is called a circular path. So, in this path, when compared in the two paths, when compared to the 2 points, the P1 has the more potential than P2. Why? Because it is nearer to the origin, right? So when the field should be going to far away from the origin, its strength, its potential strength will be keep on going to decrease. So that's why the P1 is nearer to the origin. That's why it has the more potential strength than the P2. Now we can calculate that what is the potential integration with respect to the P1 and P2 with by using the D1 D2 distance from the origin. So from this, here we are calculating the capacitance value of a single conductor. Right. So if the charge moves from P1 to P2, so if the charge will be moved from the P1 to P2, then energy, which is nothing but voltage drop from P1 P2. Now if you consider this path, so here P1 will be happening P2, and this is the path in between this dot, the voltage, the potential drop will be occur. In order to find the voltage drop from P1 to P2, it is obtained the voltage difference between exponential equipotential surface passing through P1 and P2. Why? Because if you considering that a strand conductor and solid conductor, the surface will be different in the standard. Why? Because there is a number of strands are overlapping with each other, and there is a huge amount of gap between the each strand. And here, when compared to the solid conductor, it has the equipotential surface area. Then there is an allowance of equal passing of charges through the entire line. Now, from this circuit diagram, we can calculate that what is the voltage drop, potential drop across the points among P1 and P2. Right. Now here let me take the value that is given by the voltage drop between 1 and 2. Now here the points 1 and 2 was make the distance from the origin, it is given by T1 T2 and E into ds. So this is the value is given to them. What is the potential drop across V1 and 2? Now if you substitute E value in this equation, Q divided by 2 pi epsilon x dx. Now, if you integration of 1 by x is given by ln x. So, if you substitute upper and lower limit, you will get V12 is equals to Q by 2 pi epsilon ln D2 by D1. So, this is the voltage drop across the voltage drop in the conductor due to the points P1 and P2 when it is having the distance from the origin D1 and D2. Now, the voltage drop between the 2 points may be either positive or negative, depend on the charge causing the potential difference is positive or negative. So based on if it has the positive charges, then your potential difference will be positive. If it is having the negative charges, then you can get the negative. So if you want to get the total voltage, you have to calculate the voltage by considering the positive voltage drop, the voltage due to positive charge plus the voltage due to negative charge. Then only we can consider that total circuit value. And it also depends upon whether the voltage drop is computed from point near the conductor or to a point far away. So here there are two points we are considering here. One is what is the voltage should be happen with respect to the charge capacity, that is a positive or negative charges, and also what is the voltage drop is computed from the near point and faraway point. So I already told you that if you consider the P1 and P2, if P1 is nearer to the origin, that is conductor, and it has the high potential than the P2 value. So these two parameters are considering that based on that distance and charge values. Next, capacitance of a single phase line. So until now we derived that what is the equation of, so this is the voltage value. So generally what is the capacitance value? C is equals to Q by V, right? So if you substitute here, you will get the capacitance value. The same thing we will get that what is the capacitance value of the single phase line. So single phase line is nothing but it consists of two conductors, one is phase and another one is neutral. So here I am considering that two conductors, it is phase and neutral, and these two conductors are separated by the D, and its name is A and B. The conductor A having the radius RA and conductor B having the radius RB. The conductor A will having that positive charges and it having the negative charges. If you want to find the total calculation of capacitance, we need to consider that both positive charges as well as negative charges. Now, so this is the formula was given by the capacitance value. C is equals to Q by V. So Q actually in inductance we formula is pi by V, pi by I. So the inductance is depends on that flux linkages and the capacitance depends on the charges. Here current is involving, here electrical field is involving, that is voltage is involved. So that is the difference between these two formulas. Now, the capacitance of a single phase line is obtained by substituting in above equation V in terms of Q. So we have to substitute instead of V, we have to substitute the Q in terms of Q value. Then only we can calculate that capacitance. Now, consider a single phase overhead transmission line consists of two conductors A and B, and here A is called as phase conductor and B is called as neutral conductor, which are separated by a distance of d in air as shown below. So we have to why because there is a permittivity is acting on this between the two. Why? Because there is a air gap between these two conductors, right? So here the permittivity of air will be acting here. Now you will see that when we substitute V value, that is V value in this equation in terms of Q, what will happen? Let me see. Right. So the charges on each conductors are separately positive Q and negative Q coulombs per meter length. Why? Because I already told you that it is a parallel plate. It should be look like a parallel plate capacitor. It should be like this. And here in this first place, the positive charges are entering here and the negative charges are terminating at this terminal. So that is the reason I'm taking the positive charge here in this conductor and negative charges in the conductor. Now, how we can find the capacitance of the total circuit, it including both positive and negative charges? First of all, we have to find the voltage drop due to the plus Q and of conductor A, and similarly we have to find the charge we had voltage drop due to the charge minus Q on conductor B. After that we have to add both voltage drop, then only we can find the total capacitance value. Then by using the principle of superposition. So here superposition a principle is involved. Why? Because if you want to find that voltage drop in the conductor A, we have to open the conductor B. So what we did in superposition theorem, same procedure happening here. So if your circuit having the two voltage sources, if you want to find that one voltage source, you should have to eliminate the other source. The same thing, if you want to find the voltage drop due to the positive Q, we have to eliminate this term, this minus Q, and if you want to find this one, you have to eliminate this. So it should be obtained by adding the superposition theorem. Next. So this is the basic formula for the voltage across the two conductors. So it has the two conductors, namely AB. So what is the formula for Q divided by 2 pi epsilon Ln d2 by d1? This is the formula we obtained in the electrical field, that is voltage. Now so this is the value for only one conductor. Now here we are calculating for the two conductors due to the positive Q and the negative Q. So at this condition we have to use this formula, and this formula we can use based on the number of conductors. So here M is denoted as number of conductors. We have 2, 1, 2. So QM, that is charge with respect to the conductor 1, charge with respect to conductor 2, and d2 by d1. So if you expand this equation with respect to the 1 and 2, you will get VAB, that is voltage across the AB is equals to 1 by 2 epsilon Q1. So first one, when you substitute M is equals to 1 Q1 ln d21 by d11 plus Q2 ln d22 by d12. And this is the equation of voltage drop across the two conductors A and B. Now already we know that the charges at the two parallel plates are equal, but the sign is different. Now here I am considering that QT is equals to minus Q1 or totally Q, and D11 is a RA, that is self distance, and D2 is also self distance, and D12 and D21 is the distance, this GMT, distance between the two conductors. Now if you substitute these all parameters in above equation, let me see what we will get. Right. See here, if you substitute 2 instead of 2 1 like this 1 1. So here D21 D12 is equals to D, and D11 equals to R1 RE, that is RA. D22 is equals to RB. Now substitute here, then I already told you that QT is equals to minus Q1. So instead of Q2 I substitute here minus Q1. Now let me take the Q1 is a common on both terms, then bring the outside. So Q1 by 2 pi epsilon into Ln d by RA minus ln dB RB by D. Now, so when the formula, right, ln A minus ln B is equals to ln A by B. From this formula, finally we'll get VAB is equals to Q1 divided by 2 pi epsilon into ln D square divided by RA RB. Now, it both having that. So RARB means when the two conductors having the same radius, what we will get? Ln D square by R square, right? So we can write ln D by R whole square. So when we rearrange this, you will get 2 into ln D by R square. Let me see what we'll get. See here, this is the we found that VAB, that is ln D square by RA RB. Now from this value, if you substitute VAB value here, QQ get cancelled, then you will get the formula like this. Now here we are considering the two same conductors, same size, then it has the both radius are equal. Now instead of RA RB, I am substituting R, then you will get D square R square. Now when we bring the whole square, then it comes to the 2 ln D by R. 2 get cancelled, then capacitance of the single phase line is given by CAB is equals to pi epsilon A divided by L and D by R. So this is the formula when considering that the single phase two conductors, single phase two line. Now if you consider that if you consider the three phase line, we had to calculate that one phase to neutral, one phase to neutral, one phase to neutral. At that condition, so it is required to find the capacitance between one of the conductor and the neutral point. It is given by, this is the one, CAN is equal to CBN. So CAN is the one phase and neutral, and this is one phase and neutral, and you will get 2 pi epsilon divided by L and D by L. Now, if you want to total capacitance, you will get CAN plus CBN. Now you will get the formula like this. Why? Because these two the conductors are connected in parallel. Right. Now the idea of capacitance to neutral is shown in figure. Suppose if you calculate in the capacitance between the two phases, where you are calculating CAB, that is given by 5 pi epsilon divided by L and D by R. Now, if you want to find that with respect to neutral, then you will get, it should be shows like this. So CAN, CBN, if you add this both, you will get CAB. So CAB is nothing but the capacitance between the conductors A and B. CAN is the capacitance between the conductors and neutral point. Similarly, CBN, so conductor neutral point. So here CAN equals to CBN equals to CN is equal to 2 CAB. So it is a 2 times of CAB. Now finally, if you substitute 2 CN, that is 2 CAB, 2 pi epsilon, you will get 0.055 divided by L and DR new microfarad per kilometer. So this is the way we have to this is the formula when we have to find the capacitance value of conductor with respect to the neutral, and this is the form, that is CAB is equals to 5 pi epsilon L and D by R. This is the capacitance of two conductors, and 2 pi epsilon divided by L. So this is the capacitance with respect to the one phase and neutral point. And this equation is given by the capacitive reactance, that is 1 by 2 pi f c. So for reactance of inductance is given as XL equals to 2 pi f L. So it is completely similar to the inductance derivations what we derived in the previous classes, and just to practice that derivation, then only you can understand this question. And you have the exam on Thursday on this first unit. So students, keep remember that you have exam on Thursday. So maximum up to Thursday. So I'm trying to complete the syllabus of first unit. Okay, no problem. Don't worry. I will send you notes. In that notes, there are number of problems you have, and so why? Because we have less time to complete the syllabus. So up to this and this is the time 16 days, 16 classes. So that's why I'm going to be paused. So don't worry. If you have any doubts, I will send the material and you can go through that. యా షూర్ ఈ రోజు జరిగిన క్లాస్ వరకు నేను ఇప్పుడే సెండ్ చేస్తాను. దెన్ యూ కెన్ సో ఆల్రెడీ ప్రాబ్లమ్స్ కూడా ఉన్నాయి కదా, ప్రాబ్లమ్స్ కూడా ప్రాక్టీస్ చేసుకోండి. ఇంకా మీకు ఏ రోజు జరిగిన క్లాస్ ఆ రోజే మీకు మెటీరియల్ సెండ్ చేస్తాను. సో డోంట్ వరీ. సో మెటీరియల్ వరకు మీకు పక్కా 100% ఇచ్చేస్తాను. బట్ యూ హ్యావ్ టు ప్రాక్టీస్. సో డోంట్ స్టడీ ది సబ్జెక్ట్. అంటే ఈ సబ్జెక్ట్ జస్ట్ మీరు ఈ సెమిస్టర్ ఎగ్జామ్ రాసి పాస్ అవడానికి మాత్రం చదవకండి. So this subject will be useful for your future. So if you want to write any competitive exams or gate exams, definitely it is a helpful for you. Okay na? So maximum score చేయడానికి ఈ సబ్జెక్ట్ చాలా యూజ్ అవుతుంది. సో ఎంతో ట్రాన్స్ఫర్ తీసుకుంటే maximum questions you may get from this transmission line parameters alone. సో ట్రాన్స్మిషన్ లైన్ పారామీటర్స్ పైన మాక్సిమం 10 క్వశ్చన్స్ దాకా అడిగే ఛాన్స్ ఉండదు. సో అందుకని ఈ సబ్జెక్ట్ లో ప్రతి ఒక్క టాపిక్ ఇంపార్టెంటే. సో మీకు ఎటువంటి కన్ఫ్యూజన్ లేకుండా నీట్ గా ఎక్స్ప్లెయిన్ చేసే బాధ్యత నాది. సో ఐ విల్ గివ్ ద నీట్ మెటీరియల్ ఆన్ ది సబ్జెక్ట్. ఐ విల్ గివ్ ద నీట్ ఎక్స్ప్లెనేషన్ ఆఫ్ ది సబ్జెక్ట్. ఓకేనా? So this is about, so until now we discussed about capacitance, how we can apply the capacitance formula. So capacitance formula we can obtain by Q by V. So don't forget this formula. So we have to bring the equation in terms of C is equals to Q by V. ఓకేనా? అదే మనకి ఇండక్టెన్స్ లో ఏమొస్తుంది, psi by I వస్తుంది కదా. సో ఈ రెండు ఫార్ములాస్ బాగా గుర్తుపెట్టుకోండి. సో we have to bring this every equation of capacitance in the terms of Q by V. ఓకేనా? Right. So okay students, this is about today's class. I'm going to end this class now. Thank you.